All right, class, today we're going to be focusing some more on operations associated to matrices, specifically looking at multiplying matrices. So a matrix A and matrix B can be multiplied if and only if the number of columns in A equals the number of rows in B. All right, let's go over this one more time because I think it can be a little confusing at the beginning. So A and B can be multiplied if and only if the number of columns in A, so we are talking about the columns in A, equals the rows in B. Okay, so we are comparing columns to rows. So if matrix A has dimensions m times n, and matrix B has dimensions n times p, then the resulting dimensions of A times B would be m times p. Okay, so in essence, we are taking this matrix and we are multiplying it by matrix n times p. And you can kind of think about, all right, the n's are absorbed, so they disappear, so we're left with m times p, which is the product of matrix A and B. So let's take this into account and consider these next following examples. Using the matrices on the left, determine if the product is defined. If yes, give the dimensions of the resulting product. So if I'm looking at A, D, notice that matrix A is what? 1, 2, 3, 4. So it's going to be matrix A is a 4 by 3. Okay. Matrix D is then, if I look at D, this is a 1, 2, 3 by 1. Okay, so if I were to multiply these in this order, A times D, then I would be taking a 4 by 3 and multiplying it by a 3 by 1. Okay, so since the columns in A match the rows in D, we can do this multiplication, and our resulting matrix will be a 4 by 1. Okay, so remember, it's always whatever's on that outer side, that 4 and this one. And so can we do it? Yes. Okay. All right. Now I'm going to have you try a couple of these. Let's try AC. So for AC, we have a 4 by 3, which is A, times C, which is going to be a 2 by 4. Now, because the rows in C do not match the columns in A, the answer to this is no. We cannot multiply these. All right, let's try a couple of these other ones. BE. B is going to be a 1 by 1, 2, 3, 4, 5. So that's a 1 by 5. And we're multiplying that by E, which is a 1, 2, 3, 4, 5, a 5 by 2. Because these match, we can do the multiplication. So the answer is yes. And we're left with the matrix 1 by 2. All right, BD. If I look at B, that matrix is going to be a 1 by 1, 2, 3, 4, 5 times D, which is a 3 by 1. These do not match. So because they do not match, can I do the multiplication? No. Okay. All right, let's look at the next couple ones. Number 5 here. C is going to be a 2 by 4. And A is a 4 by 3. So because these are the same, the answer is yes. And our resulting matrix is going to be 2 by 3. EC, so I have a 5 by 2 times C, which is a 2 by 4. Again, these match. So my resulting matrix is going to be a 5 by 4. EB. So if I look at E, I have a 1, 2, 3, 4, 5 by 2. And we're going to times that by B, which is going to be a 1 by 5. The outer ones match, but these ones do not, so the answer is no. Okay. Now, what about DB? So if I look at DB, D is going to be a 3 by 1, and B is a 1 by 1, 2, 3, 4, 5. And so this is yes. And the result is a 3 by 5. So I want to point something out real quick right here. Notice I have B, E, and EB, right? Notice how the multiplication of these two matrices matters. Order does matter, because if I do B times E, then they match. And so I can, in fact, multiply. I ended up with a 1 by 2. But if I do E by B, they no longer match, right? So the rows in E do not match the columns in B, so I cannot do the multiplication. So order matters in matrix multiplication. It is not commutative like it is in numerical, just regular number multiplication. All right. How do you multiply matrices? So this is the next, this is really how we go about multiplying these matrices. So let's look at this definition here. The element in the nth row and the nth column of the matrix AB is the sum of the products of the corresponding elements in row M in matrix A and column N in matrix B. Show this pattern below. So I can see that this can be really, really confusing. So let's look if we were going to multiply this. So what would that equal? What would that multiplication equal? So what's going to end up happening is we are going to take this first element, A, and we are going to multiply it by this element here, E. So that would be A times E. Okay. Now then we are going to take B and we're going to multiply it by G. Okay. And then that we would add that B times G. So we are taking this row, we are multiplying it by this column, and that gives us the first entry, the first element. Okay. Now let's take a look at the next one. So for the next one, here, we would take C and multiply it by E. And then we would add up and we would take D and multiply it by G. So we are taking this row and multiplying it by this column. And that gives us the lower element. Okay, now let's take a look at the top element B. So how do you think that we get this column right here? What are your thoughts? All right, so what we're going to end up doing is we're going to take now this entire row, and now we're going to multiply it by this column. So it's going to be A times F plus BH. Now, how do we calculate this one right here? Well, that would be this row times this column. So it'd be CF plus DH. All right, let's look at this in practice. Let's try some of these. So looking at this first one, we're going to multiply it out. So first we have to decide if it's possible. So this is a 2 by 2 matrix, and I'm multiplying by a 2 by 2 matrix. So because these rows match these columns, we are good to go. So let's go ahead and figure out the multiplication, okay? So now I'm going to start off by taking this row and multiplying it by this column, and that's going to be the first one, okay? So that row times this column, so it's going to be negative 4 times 6, that gives me a negative 24. Negative 9 times negative 5, that's going to give me a positive 45. Okay, so that's the first element. We'll add it up in a second. Now we're going to take this row, multiplying it by this column, element by element. So 3 times 6, that's going to give us 18, plus negative 2 times negative 5, which is a positive 10. So now we're going to the top right-hand corner. So it's going to go this row times this column. So negative 4 times negative 1 gives me a positive 4. Negative 9 times 4 gives me a negative 36. And our last element is going to be this row times this column. So 3 times negative 1, that's going to give me a negative 3. Negative 2 times 4, that gives me a negative 8. So now I'm going to add these up. So negative 24 plus 45, 18 plus 10, 4 minus 36, and then negative 3 minus 8. So I end up with 21, 28, negative 32, and negative 11 as the solution. So that would be the product of those two matrices. Okay. All right, I'm going to go ahead and pause this video. I want you to try this one because number 10 is very similar to what we just did. All right, here's the solution to number 10. All right, so we should have ended up with negative 16, 6, 40, negative 54. Just double check your work to make sure that that's what you got. And let's try another example. So in example number 11 here, right here, let's check that we can do the multiplication. So this is a 2 by 3, and this is a 3 by 1. So it does definitely check out because those match. This means that our result should be a 2 by 1. So in this case, we're getting a smaller matrix. So let's do the multiplication here. So I'm going to take this row by, this row by this column, So negative 7 times negative 6 plus 2 times 4 minus 11 times negative 3 goes in that top one. And then notice, because I don't have another column, that's kind of the end of that top. So now we're left with the bottom, which would give us 3 times negative 6 plus negative 5 times 4, and then plus negative 2 times negative 3. Okay. Well, negative 7 times negative 6 gives me a positive 42 plus a 8 plus 33. So on that top, we're going to end up with 42 plus 8 plus 33, which gives us an 83. On that bottom, 3 times negative 6, that gives us a negative 18. Negative 5 times 4 gives us a negative 20. Negative 2 times negative 3 gives us a positive 6. So negative 18 minus 20 plus 6, that gives us a negative 32. So we are left with a 2 by 1. And this is our final answer. Okay. All right, let's take a look at number 12 here. So here we have a 2 by 1, a 1 by 2. And we're multiplying that by a 2 by 4. Our 2's match out, so yes, we can do the multiplication. This time our result's going to be a 1 by 4. So one row with 4 columns. Well, let's take a look at that first. So we're going to take the row multiplied by this column first. So we get 2 times 3, that gives us 6. And then we're going to add negative 8 times negative 2, which is 16, so 6 plus 16. Then we're going to end up multiplying by the next column. 2 times 10 gives us 20. And then we have negative 8 times negative 7, which gives us a positive 56. Then we move on to the next column, sorry. 2 times negative 4 gives us a negative 8. And the negative 8 times 5 gives us a positive 40, negative 40. And lastly, now we're on our last column here. So we have 2 times negative 3, which gives us a positive 6, and the negative 8 times negative 6, which gives us a positive 48. And I lied, this is a positive 2 times a negative 3, that should be a negative 6. So we said it was only going to be a 1 by 4, and that's what we see here. So now let's go ahead and simplify these numbers. 6 plus 16, that's going to give us a 22. 20 plus 56, that's going to give us a 76. Negative 8 minus 40, that's going to give us a negative 48. And then negative 6 plus 48, that's going to give us a positive 42. Okay, and that's our resulting matrix that we multiplied. All right, let's pause here and I'll give you another opportunity to try the next few. And we'll pause in between. So go ahead and take the next one on. All right, for number 13, did you get this matrix? 10, negative 69, 30, and 52 as your matrix. If you didn't, go back and check your arithmetic. Remember, you're going this row, times this column first, and then you're kind of making your way through. Okay, and then you're going to go this row times the next column. Okay. All right. Now, the next one, we do have a 3 by 1 times a 1 by 3. What's kind of cool with this one is that what we see here is that these ones were good, but then we end up with a 3 by 3. So in this particular case, we went from somewhat smaller matrices. We're going to go to a larger matrix, to a 3 by 3. Okay. So let's go ahead and try this one out. So when we multiply, remember, we're going to go 14 times negative 1. So this time there's no addition because it's just a row by the column. So 14 times negative 1, that's going to give me a negative 14. Okay. Then I have 2 times negative 1, that's going to give me a positive 2. Negative 6 times negative 1, that gives me a positive 6. So now I'm moving over. So now it's this whole column, this row times that column. All right, for the next column that we're constructing, we're going to take 14 times the next column. So 14 times 9, that gives me 126. Okay, for the next element here, that's going to be negative 2 times 9, which is going to give me a negative 18. And then we're going to have negative 6 times 9, which is going to give me a negative 54. Right? Now we're on our last column here. We're taking 14 times 5, which gives us a 70. Negative 2 times 5, which gives us a negative 10. Negative 6 times 5, which gives us a negative 30. So you can see this one builds out to a 3 by 3 matrix. So it became larger. All right, go ahead and try number 15 on your own. Make sure to check that the multiplication is possible. All right, for number 15, now that you've tried that, did you obtain the matrix 10, negative 69, 30, 52? All right, you can check out some of the additions here on the matrix above. Okay. Let's do 16 quickly together. I think we can get this one done fairly quick. So this is a 2 by 1 being multiplied by a... Sorry, I said this backwards. This is a 1 by 2 being multiplied by a 2 by 1. So notice that my 2's are there, so we're going to end up with a 1 by 1 matrix, which means we're going to end up with one value. So here I'm going to take this row multiplied by this column. So I'm going to get negative 7 times 16 minus 5 times negative 1. And that's the entire matrix. So then when we do that, we end up with negative 112 plus 5, which gives me negative 107. And this is the matrix. That's it. All right. Let's take a look here. So we're going to start looking at specifically some of the properties of matrices. But in this particular case, we've already talked about this briefly. So given matrix A and B to the left, find AB and then find BA. What can we conclude about the results? So when we look at AB, that would be 3, 4, negative 1, 8, being multiplied by negative 2, 7, 10, 6. So let's go ahead and calculate this. So this matrix, I'm going to take this column, multiply it by this column. So I'm going to end up with negative 6 minus 7. Then I'm going to take this column, 4 times negative 2, which is going to give me a negative 8. 8 times 7, which is going to give me a positive 56. Okay, let's come over here to the next column. 3 times 10, that's going to give me a 30. Negative 1 times 6, that's going to give me a negative 6. 4 times 10, that's going to give me 40. And then 8 times 6, that's going to give me a positive 48. So my AB matrix I end up with is negative 13. Negative 8 plus 56 gives me a positive 48. 30 minus 6 gives me a positive 24. 40 plus 48 gives me a positive 88. Okay, let's look over here. Let's look at the next one. Here we're looking at B times A. So in this case, we're taking negative 2, 7, 10, 6, and we're multiplying that by 3, 4, negative 1, 8. So negative 2 times 3 is 6, negative 6. And then we have 10 times 4, which is 40. Then we have 7 times 3, which is 21. And we have 6 times 4, which is 24. We move over, and then we have negative 2 times negative 1, which is a positive 2. 10 times 8, which is an 80. Then we end up with 7 times negative 1, which is negative 7. And 6 times 8, which is a positive 48. We're going to add these all together. Negative 6 plus 40 gives me a positive 34. 21 plus 24 gives me a positive 45. 2 plus 80 gives me a positive 82. And then negative 7 plus 48 gives me a positive 41. So notice that they're very different matrices. So here I have a negative 13, 24, 48, 88. But those are very drastic difference. So this is telling me that AB, the multiplication of matrix A times the multiplication of matrix B, does not equal B times A, the multiplication of B times A. Therefore, the commutative property does not work with matrices. And we kind of saw that earlier when we were talking specifically of the dimensions. Remember how I talked about BE and EB, right? So that commutative property does not exist when it comes to matrices. It does not work. All right, let's look at other properties of matrices. So in this particular case, we have the associative property of matrix multiplication. Excuse me. That means that if I had two matrices, A times B, and I multiply a third matrix, C, I can multiply them in a different order, where I can multiply matrix B times C first and then multiply matrix A. Associative property of a scalar. So scalar just means a numerical value. So we usually call that K. So in this case, we can have a scalar K times the matrix AB. And so this would be the same thing as taking the scalar K times the matrix A and then multiplying matrix B. Similarly, I could take A and multiply the scalar with B first and then multiply A. All of these are true and they hold. The left distributive property. So this means that if I take C on the left-hand side and I'm adding matrix A times B, sorry, A plus B, it is the same as if I take C and I multiply it by A, then I take matrix C multiplied by matrix B and then add the two. Now the right distributive property for matrices. We have to distinguish this because of the fact that order matters in multiplication. So this would look like A plus B and then multiplied by C. So this would be the same thing as taking matrix A and multiplying it by matrix C plus matrix B and then multiplied by matrix C and then adding those two things together. Okay. All right, let's take a look at some applications here. The first table shows the number of reams of paper packs in a dry erase markers, boxes of staples requested 2 teachers. The cost per item is given in the second table. Use matrix multiplication to show that the total cost of the supplies for each teacher. All right, so the first thing we want to do is we want to be able to transition this into a matrix. So the matrix I'm going to have is going to be 6, 8, 4, 2, 5, and 3. So notice that the top one is representing this row, the bottom one is representing this row, and then we have paper, we have markers, and we have staples. So now when we look at the next matrix that we're going to multiply, notice that we have paper, markers, and staples. So this particular matrix is going to be 15, 4, and 2.5. So notice that when I multiply, I'm going to be multiplying papers times the price of papers to get me that first entry. And now notice that this is a 2 by 3, which I'm multiplying by a 3 by 1. So my final answer should be a 2 by 1. So let's do this. So I would end up with 6 times 15, which gives me 90. But then I would have 4 times 4, which give me 16. And then I would have 5 times 2.5, which is 12.5. All right, our next one, now we take this row, we're multiplying it by that column. So 8 times 15, that's going to give me 120. And then 2 times 4, that gives me 8. And then lastly, 3 times 2.5, which gives me 7.5. So we're going to add those two together. And notice that I end up with 90 plus 16 plus 12.5. That gives me 118.5. And then 120 plus 8 plus 7.5. That gives me 135.5. So because this is words, we really should answer in words. So let me remove this. So notice that this top row was Smith. The bottom was Will's. So this tells me that the total cost Mr. Smith spent is $118.50. Meanwhile, Miss Wills spent $135.50. And that's all for that one. Let's look at the next application problem. We're using this for the next couple of questions. The student at Oak Hill High School are selling bags of popcorn for $10 each, tubs of cookie dough for $12 each, and baskets of fruit for $16 each to raise money for the school. The number of each item sold per class is shown below. So if they earn 15% profit on each item they sell, use the matrix multiplication to show the profit earned by each class. Give your answer as a matrix. So they're making 15% profit on what they have here. So we need to figure out what is 15% of what is being sold. So 15% of, and then we have $10, which would be our popcorn. So then this would turn into 1.15 times 10, which is equal to 1.5. Then I need to figure out what is 15% of cookie dough, which is $12. So that's going to be 0.15 times 12, which would give me 1.8. And lastly, you need to figure out what is 15% of the basket of fruit, which is 16. So that's going to be the same thing, 0.15 times 16, which is equal to 2.4. So these are the values of our profit. So let's write out this matrix. So our matrix is going to look like 60, 84, 45. So remember, here's our popcorn, here's our cookie dough, and here's our fruit basket. So then we have the other values of sophomores, juniors, and seniors. So we have 75, 58, 28, 40, 63, 18, 91, 47, and 32. So now we're going to multiply it by, and we want to make sure that we align the profits. So it's going to be 1.5, 1.8, and 2.4. And by aligning them, we want to make sure that when I take 60 and I multiply by 1.5, that those are exactly, that's the popcorn, and that is the profit of the popcorn. And it is. That first one was popcorn. And then we're going to multiply. So let's go ahead and do this multiplication here. So we're going to have 60 times 1.5 plus 84 times 1.8 plus 45 times 2.4. So if you do this real quickly on your calculator, you should end up with 349.20. So again, we're going to take this row and now we're going to multiply it by the entire column. So 7.75 times 1.5, 58 times 1.8, 28 plus 2.4, and then we're going to sum all of that together and we're going to end up with $284.10. Now we're going to take 40 times 1.5 plus 63 times 1.8 plus 18 times 2.4, and we're going to end up with a total of 216 plus 60.60, sorry. And last but not least, we have the last three numbers here of our row. 91 times 1.5, 47 times 1.8, 32 times 2.4, and then this gives us, summing all of those values together, we get 297.90 as the matrix solution. All right, so the next question here is, which class earned the most profit? So if we take a look at which class, notice that the highest number in our matrix is this first one. So that corresponds to this row, and that's going to be freshmen. Go freshmen. Give the total profit for the school. So now the total profit, we're going to take all of these values and sum them up all together. So if you sum up all those values, we would end up with $1,147.80. How much more profit did seniors earn than juniors? So the seniors were this last one. So we would take 297.90 and we would subtract what the juniors made, which was 216.60. When we do that subtraction, we end up with 81.30. So that means that they made $81.30 more. And that's it for this section.